Hello ladies and gentlemen, today we're going to be looking at reacting mass calculations, which is a method we have to work out the masses of products and reactants in chemical equations as long as we know the mass of at least one of the other products or reactants present. Now before we carry on with this, we should be familiar with the equation N is equal to the mass divided by the relative mass, where we have N in moles and then here the mass in grams. If we're not familiar with this, we really need to be quite comfortable with it. So please go away and familiarise yourself, and especially with how to rearrange it so that we know that the mass in grams is equal to the moles times by the relative mass. Now, what we're aiming to do is be able to convert from the mass of one product or reactant to the mass of another product or reactant. So we can see in this example here, they're asking us what mass of hydrogen is produced when 6 grams of magnesium reacts completely with hydrochloric acid. And the important information we have here is that we have 6 grams of magnesium and this balanced symbol equation, which will become very important later on for solving this equation. So, first things first, we're going to convert our mass of magnesium into an amount of moles of magnesium. I always find it best to try and tell people explicitly what I'm doing. So I'm going to put a little note here that my moles of magnesium is what I'm working out. So I know that moles is equal to mass over relative mass. So if we substitute in our figures, we've got moles is equal to the 6 grams of magnesium over, in this case, 24 grams per mole for its relative atomic mass. And that should then give me an amount in moles of magnesium of 0.25 moles. What I need to do now is find out how many moles of hydrogen this amount of magnesium will produce in this reaction. And what we need to do there is look at the balancing numbers, or the stoichiometry, between magnesium and hydrogen. You can see in this example that they both have nothing written in front of them, which means they actually have a balancing number of 1. So the ratio of magnesium to hydrogen is 1 to 1. So for every 1 mole of magnesium, we would expect 1 mole of hydrogen gas to be produced. So we can hopefully see therefore that if we have 0.25 moles of magnesium, we should end up with 0.25 moles of hydrogen at the end of the reaction. So our moles of hydrogen is 0.25. Now in the question they've asked us to work out the mass of hydrogen produced. So yet again, just noting down what I'm doing, so my mass of hydrogen is going to be equal to the amount of moles times by the relative formula mass. So my first step here is to work out the formula mass of hydrogen, which by looking at the periodic table, I can see hydrogen has an atomic mass of 1, and there's 2 hydrogen atoms in a hydrogen molecule, so 1 plus 1 equals 2. And then by substituting the amount in moles, which is 0.25, and the formula mass, which is 2, into my equation, I can hopefully see that I'm going to end up with a final mass of 0.5 grams. So my final mass of hydrogen I would produce is 0.5 grams. So let's just recap the steps we've taken here. First things first, we've worked out the moles of magnesium, and we found that we produced 0.25 moles of magnesium. We've then looked at the balancing numbers, or the stoichiometry, to discover we've got a 1-to-1 ratio of hydrogen to magnesium, which means that if we have 0.25 moles of magnesium, we must have 0.25 moles of hydrogen. Before finally using the equation mass is equal to moles times formula mass to work out the final mass of hydrogen we could produce in this reaction, which is 0.5